Now it's helpful to watch the previous videos on rocks before watching this one, otherwise I may be skipping and some things may not make sense. All right. So my initial, what I was doing yesterday, I was thought, I'm going for a big walk, a big hike, bushwalk kind of, and let's go get some more of these really cool rocks here that have these interlinking cross links, these quartz rocks. And so I just spent some time looking, went to a place where there's lots of rocks, and I got this one here, and I thought, oh, cool, this one's even better than the one I've got. It's got like these massive, huge, and it goes thin to thick. It's got these massive veins, quartz veins. So I thought, cool, I'll go home and I'll analyze that. And so a geologist probably would have known straight away that I've got a completely different rock, a completely different mineral, and a completely different process. I'm so far off the mark, it's not funny. So the first one is, you can see here, it's a sedimentary rock that's gone sort of metamorphic now, and it's still porous. It's recrystallized. So through the metamorphic process, the veins have recrystallized. And in a previous video, I've shown the geologist report on that. And so I should have known already, because I should have known that this is a lighter and they're quartz veins. So the quartz feldspar muscovite, they're buddies, and you'll always see them together. And what I have is a very dark rock, and so it's on the other side, the olivine pyroxene side of things. And so you don't see the two together. Now I looked up quartz veins, and apparently you can get, after the rock is formed, you can get quartz precipitate out. But I know silicon dioxide is insoluble, but apparently there's this thing, orthosilic acid, and so there is a chemical that contains silicon and oxygen that can precipitate out. But I'll cross that bridge when I come to it, because I've never seen it, and I'm just working off the evidence I have right now. And so the first thing that was sort of like struck me really was the fact that the crystals looked like calcite, and they were all rhombic, and I thought, oh my god, that cannot be, they're not the hexagonal crystal shapes, they're the squares, so it can't be quartz, it must be calcite. So it's not a quartz vein, it's a calcite vein. And so just to double check, just to be sure, I'll just show you the quartz veins. It's still porous, even though it's metamorphic, so you can see the water still soaks into it. You can see the granules. So the parent rock was sedimentary, and there's no bubbles, so the quartz is not reacting with hydrochloric acid. And then if you go to the calcite vein, you can see that it bubbles quite vigorously. So that's the test for calcite, which is not just in calcite crystals, but also in limestone and marble. Okay, so it's definitely a calcite vein. So there's a little bit more to it. It must have arrived because if you have a careful look at the rock, you can see that it has lots of dark crystals there. So it's a basalt. It's a completely different rock. It's an igneous rock, and it's on the mafic side. It's very dark, so it must contain lots of iron and magnesium. You can see here there's lots that looks like little tiny olivine crystals. You can see it's weathered quite a lot too. So this one here, you can see it's quite dark with basalt with very fine crystals. And so it's not a sedimentary, it's an igneous rock. Probably no metamorphosis there at all. And you can see here that you can see here that it's full of iron, and so it's very red, and so there's a lot of iron oxide weathering, and there even seems to be a slight vesicular inclusion, like a gas bubble with crystals inside right there. It's not pumice, but that's a sign of the basalt that has that's come out very quickly and cooled very quickly. And here's a classic olivine crystal, this little green inclusion here. And if you look up closely, you can see it's a mixture of different crystals. And so olivine is usually a mixture of different colored crystals in there that I'm used to. And you can see it there. And so it's clearly quite deep inside the crust. The olivine crystals and the gas bubble have been grabbed, or the olivine crystals been grabbed, and the basalt's cooled very quickly. And so it's quite a different rock. And then, so what must have happened is after the rock has formed, there's been cracks, and hot water with calcium carbonate has gone through the cracks, and then the calcium carbonate, which is very slightly soluble, but if it's hot and under pressure, it's more soluble, and it very easily precipitate out, and that's how we get the calcium carbonate crystals. So very different rock, very different process, very different to the sandstone where the quartz that's in there already has just melted a little bit and recrystallized.